I'll pull it here. Because they have available for 7, which is not the one. I have a good reading.
I'm the first one, class.
I think that Mark was the first one.
I'm the first one. I'm like closer to your desk, so I'm like.
Yeah, but he came into advisory first, so he's been in here longer.
Oh, that's true. I was second to class.
So you're the first loser then?
Oh.
You know when the test is, because it says October 4th.
Oh, that would be, should be 11.
Oh,
So we're aiming for 11-4, not 10-4.
Because I'm just such a joy. Alright, next. No, I get it. She's not here. You want to? No, I just want Do I really want to sit by you? Or sit by you and make you go last? But I don't. Sit by your boyfriend and then you ask Danielle to move by you. Because you know she will. And you know she has no.
away.
No, don't do that to me ever again. I swear.
I know, I'm so scared of like a ninja. Angel.
I got Every night. I just don't take meal breaks.
I only have one right now.
Okay, you guys will need your assignment 40 out of your backpack later, and you'll need a blank piece of paper. So if you want to take a minute to get 40 and a blank piece of paper out, I will give you the rundown of class today while you do that. Okay, so we've got 3 big things we're looking at here. We're going to start the next topic. So 2 of the pages you picked up on the way in make up assignment 42. We're not going to do all of that today. I want to tell you what extreme value theorem is, talk about how it works, talk about how to justify your answers, and practice a few of those. So we will finish up 42 another day. The second thing we will look at is assignment 40 from last class. I am not asking you to turn that in today because I wanted to give you a chance to ask a question or two from the end of that assignment. So if some of you didn't finish it in class, there was very little help on the website, so that's why I'm offering you a chance to ask a question or two from that. But I will be asking for number 40 to be turned in next time, Google Classroom or in person. And then finally, 41 is the practicing of the stuff we had talked about last class, and I meant for you to do it last class, but we ran out of time. So, finding critical points, figuring out where a function's increasing, decreasing, finding relative extrema. All the stuff we practiced on assignment 40. So, those three things make up our class today. So, assignment 42. Determine absolute extrema from candidates. So before I dive into what's different today, let me talk about what we did last class and how this one's different. So last class we talked about if you have a graph and it looks like this, if we can figure out where the slope is 0 or undefined, known as critical numbers, then that's the only place the graph might be changing direction. And if you know where it's changing direction, we can plug in values around those critical numbers. Positive derivative means positive slope, means it's increasing. Negative derivative means negative slope, means it's decreasing. And then we can figure out when it's increasing, decreasing. And anytime it goes from increasing to decreasing, we get a relative max, or a local max, whatever you want to call it. And anytime it goes from decreasing to increasing, we get a relative or local min. So we're doing something similar today, but instead of just relative min and maxes, we're talking about absolute min and maxes. So not just the biggest value within a small set of data, or the smallest value in a small set of data, but the absolute biggest and smallest y values. Okay, so this process is a theorem in calculus called extreme value theorem. I'm going to emphasize the name extreme because absolute or global or the extreme max and mins, there's a lot of different ways for you to be asked for local or absolute extrema. But the extreme values is what EVT tells you to find. Now, before I tell you how to apply EVT, this is one of the, in calculus, there's considered to be big three theorems. You've seen intermediate value theorem the first couple weeks of school, and you probably need to review that before the AP exam. Today we're going to talk about extreme value theorem, and then also in this unit we do something called mean value theorem, but you have not seen that one yet. Okay. So before I tell you how it works, let's make up a quick little example here. Okay, let's do something like this. We're going to have x equals a, b, c, and d. Okay. What x values give us relative maximums? Where is there a relative maxima picture? B. It's going from increasing to decreasing. So there's a relative max. Where is there a relative min? A is not a relative min because nothing, to be a relative min, it has to switch from decreasing to increasing. And there's nothing over here. So it's not switching from increasing or decreasing to increasing. So not A, it would only be C, decreasing to increasing. Okay, but that's not what we're focused on today. We're focused on where do you think the biggest y value occurs? B. So the absolute could be a relative. This was a relative max, but it also turned out to be an absolute max. And that occurred at a critical number. This is where the derivative is 0. But the absolute min The absolute smallest y value is over here at A. So sometimes the absolute extrema occur at critical numbers. Critical numbers are likely to be relative extrema. Relative extrema could be absolute extrema. But it could also be the very ends of the graph, the endpoints. So extreme value theorem doesn't really say much. It says that if you want to know the absolute extrema, the biggest and smallest y value, you need to test critical numbers, which we've talked about last class. That's where the first derivative is 0 or undefined. Or it could be at an endpoint, like this example up here. So if you want to figure out which x value has the biggest and smallest y values, without extreme value theorem, you have to basically think of the entire graph. You got to think of any x value and whether it has a bigger y value or smaller y value than everything else, which is very tedious. But because of extreme value theorem, this usually narrows it down to just about 3 or 4 spots that we have to look at. Okay, so to say that, or to apply that, so find absolute max and absolute min of this graph, which I have no idea what it looks like. This would not be calculator related, because if you could just graph this in your calculator and look for min and maxes, that's what you did in Algebra 2. This is calculus. So I would see this, absolute min and max, and what goes off in my head is that's extreme value theorem. It's fine if you don't recognize it's extreme value theorem, but the nice thing about recognizing it is it tells you the min and max, absolute min and max, are going to occur either at endpoints, which are given to me, or critical numbers, which I need to be able to find for other skills anyway. So, like we talked about last class, critical numbers are when the first derivative is 0 or undefined. Of course, sometimes that is going to be the harder part of the question, but it looks like there are 2 critical numbers, 0 and 2. So, extreme value theorem says you need to test all the critical numbers and you need to test the endpoints. It gives me going from an infinite number of values to check to 4 values to check. Now, these are the x values. I would like to know the corresponding y values. So the next important thing is, if I want to know the y value, should I be plugging in x values into the derivative or into the function? Into the function. Now this is, I know I've said this a few times, but it's going to be even more important next class. If you want a point, you plug into the function. If you want to know something about the slope, you plug into the derivative. And it's important to start organizing that information, because next class we will also do things with the second derivative. Sometimes you plug in values into the second derivative to find out other things about the graph. So I could do all these without a calculator pretty easily. Some of them are easier than others. If I plug in 0 into all this, I get 1. But just for time purposes, I am going to just throw them in the calculator real fast. This is -3. When x is 4, y is 17. When x is -1/2, y is 0.125. I was able to do all those very quickly because I was using the store button. Okay, so before I forget, this little table here that shows that you're testing endpoints and critical numbers, this is what's called a candidate's test. And a candidate's test is what College Board expects to see for justification on these question types. I can promise you 100% you're going to get an FRQ on your AP exam where part of the question is going to ask you to find a max value, a min value, or both, and some of the points are going to be to the justification. Did you show that you tested the endpoints and the critical number? You don't have to say anything about extreme value theorem, but you have to be applying the extreme value theorem. Okay, now it's pretty obvious. These 4 values, this is the smallest one, so the absolute min is -3, and I could tell you where it occurs if I needed to. It occurs at x equals 2, but the absolute min value is -3. And then the biggest of these is the absolute max. And I could tell you it occurs at x equals 4 if I needed to. So most of these questions kind of follow the same pattern. Of course, the derivative can be hard. Solving for the derivative to be 0 or undefined can be harder, but it's pretty much the same thing. You're going to make a candidates test, you're going to test the endpoints, you're going to find and test the critical numbers, you're going to plug these into the function to get the y values. The biggest y value is the absolute max, the smallest y value is the absolute min. Every single time. Very consistent. But before we dive in and practice a couple of those, again, we're not going to do this whole thing today. I'd like to get through about question 4 at least, but question 2 is quite a bit different. And instead of me just telling you what it is and how I would do it, I think it's worth you guys putting a little bit of thought into it too. So first off, this is not the function, this is the derivative. They're asking, could you find the x value for the absolute max and absolute min for the function? So remember, the derivative is telling you how the function's changing. So if you know how it's changing, can you figure out the absolute max and absolute min? So I will let you think about that for just a second, and then we'll see if anyone has any educated guesses. Okay, anybody got a guess where you think the absolute max might occur? It's fine if you're wrong, but go ahead and give a guess. X equals 1 is correct. Okay, and I'm going to go over why that's correct, but any guesses on where the absolute min would occur?
3.
Not 3. What'd you say? -3 is correct. So if f prime is how f is changing, notice f prime is positive here. What do we know about a function when f prime is positive? Okay, so he's increasing, right? So the function, if this is a positive derivative, the function is going up, 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 up. Now what about this? Is the function still going up here? Yes, because the derivative is still positive. It's still above the x-axis. So it's increasing, 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 and then you get to x equals 1. Then he starts decreasing a while, decreases some, still keeps decreasing. He decreases this whole time. And then he goes back to being positive, so he increases some more. So there is some value of the function here. There is a value at -3. I don't know what it is, but I can see that it gets bigger for a while, then it gets smaller for a second, and then it gets bigger for a second. How do we know at x equals 1 that this is the biggest? How do you know it's not at x equals 4? Sorry?
It's like increasing for all that time, whereas 4 is just increasing a little.
Right, so this is going up a lot, where it only goes down a tiny bit and then up a tiny bit. So this is where why I kind of shaded in this area. If you think about this area, there's a lot more area here than there is area here. So this is the most increasing, which is why this is. But if this is decreasing, how come, and somebody did say x equals 3, how come x equals 3 is not the minimum?
Because the area shaded in is less.
Right. It started with a value less at -3. It's just that it went way up and then it just dipped a little bit for a second. So if you want to try to sketch this, this goes way up, down a little bit, up a little bit, but the minimum was where it started and the maximum was after that big run up. So it's not that this particular question is that important, but this idea of a first derivative graph and thinking about how it impacts the function is some good thought. But most questions are going to be like this. So let me do another one for you from beginning to end, and then I will have you do the next one as guided practice to see how it goes. Okay, so they want me to figure out what's the biggest and smallest y value, absolute max, absolute min. So in my head, I know that is what extreme value theorem does. I don't have to reference it, but extreme value theorem says your absolute max and min is either going to occur, like the picture on the top of the front page, at an endpoint or at a critical number. I already know the endpoints, those have to be given to me. So my first real work is to try to find the critical numbers. And again, you need to be able to know what a critical number is, you need to know why it's important, and you need to practice doing that for other things as well anyway. So first derivative, where it equals 0 or undefined. The only way it could be undefined is if you have a variable in the denominator. This guy only had one critical number, and extreme value theorem tells me the biggest and smallest have to be in this list. So I'm almost done now. I can plug in -2 into the function because I want a point. And again, this is not a hard one to do without a calculator, but I'm going to use my calculator to do them quickly. Plug 5 into the function, you get 37, and plug -1 into the function to get 1. So what is the absolute max?
37 at 5.
37, and if you need to know when, it's at 5. Absolute max. And then somebody else, absolute min would have to be 1. And if you need to know it, you know when it occurs. This is the absolute min. Now again, finding the first derivative can be harder sometimes, especially if it's product rule or quotient rule, but we're still getting better at that. Solving where it's 0 or undefined can be more difficult than this one, but everything else should be pretty consistent. Make the candidates test because it's a good way to organize the information and it counts as justification. So if you just make a habit out of doing that, then that's one less thing you have to worry about later. But then all of these basically work that way. Absolute max, absolute min is extreme value theorem. Extreme value theorem says test critical numbers and endpoints, find the critical numbers, take the given endpoints, find the y values at those x values, and then you can see the biggest y and you can see the biggest x. I guess the last question I have before I let you try question 2 from beginning to end. Why didn't I test x equals 0? How do I know x equals 0 is not going to have a bigger or smaller value?
It's not an endpoint or a critical number.
Okay, what does that matter?
This is the candidate.
Why is it not a candidate?
It's not an endpoint or a critical value.
Okay, now you're just going in a circle. Because that is not what extreme value theorem tells us. Extreme value theorem tells us these are the only ones you need to consider. You can plug in 0 if you want to, but it's not going to be bigger than this or smaller than that. You can plug in 1/2 if you want to, but it's not going to be bigger than this or smaller than this. The point of this theorem is to narrow this down to just a couple things, and so we don't have to worry about some of those other values being correct. Okay, so I would like you to try question 2, and I will go over it with you once you've had time, but I would even ask that you do as much of question 2 as you can without looking at question 1. I guess if you do get stuck, you can glance over at question 1 and see what else we did, but it should follow a very similar pattern. The work should. So nice and quiet in here without Johnny. Okay, I'm gonna cut you off here, and it's even if you didn't finish, that's okay because you at least figured out where you were slowing down. So, in the directions, since it said absolute max or absolute min, I know I should try to do extreme value theorem. Again, you never have to reference it at all, but you just need to know what it is and be ready to use it. It says test the critical numbers and the endpoints because that's where all the global extrema will come from. Endpoints already given to you. Critical number you have to work for. Find the first derivative. Find where the first derivative is 0 or undefined, which would be 0 and -1. And then to know what the absolute max and min is, this is just where they could occur. These are the candidates. So this is what's called a candidates test. This table counts as your justification for FRQs. You really should be making this anyway, but and then just make sure you're plugging these points into the function because I need points. If I plug in 0, we get 4. If I plug in -1, we get, is that 5? Okay. -2 would be 0. So I'm doing this quickly in my head, so tell me if I'm wrong. And 9. Yes? Okay. And then if you understand EVT, absolute max and min have to be right here. The smallest of the values is the absolute min. So if you graph this in your calculator and just look between these x values, the furthest down the graph goes is y equals 0. And the biggest of the values would be the absolute max. So, same thing. This is function analysis. I understand something about this function. If I graph this part of this graph, I know he only goes as high as 9. It doesn't go any higher than that. Okay with that? Okay. I'd like you to do, I'd like you to practice the next 2 also, and then we'll call it quits on this and move on to the other stuff. We'll have plenty of time for the other stuff. But just to make sure we're kind of more on the same track here, I'm going to go over both 3 and 4 with you, but I do want you to try both of them. But on 3, I want to give you a little bit of a push just in case something goes wrong here. You know you're going to need critical numbers. How are you going to take the derivative of this? Good. Quotient rule, which is obviously harder than the last couple derivatives, but let's just do that together. Derivative of x times x squared plus 1 left alone minus x left alone times the derivative of x squared plus 1 all over denominator squared. So the derivative is 1 minus an x squared over this. Obviously you should be able to do that, but I don't. What you need to understand is if you mess up the derivative, then you're going to get wrong critical numbers, and then your numbers and your answers are probably going to be different and be confusing. So go ahead and try question 3, try question 4, come up with some answers, and we will look at them as a group, make sure we're all on the same page. I guess if you're doing pretty well here, you're welcome to keep going past question 4. It's just that you don't have to before next class. I will ask you to do more of this next time though, so it obviously doesn't hurt you to do a little extra. Well, of course, if you get stuck on 3, just move on to 4. Don't waste your time.
I'm a little lost. We'll live in Pale Racer. Do you want me to leave it like that?
Well, it doesn't, I don't know. I thought it was a good idea. me give you another minute or two. I started both of them, but I didn't finish them. I'm going to talk about them in a second. Okay, so if we know the absolute max and min are going to occur at critical numbers or endpoints, and the endpoints are given to you, then really the hardest part of these questions is usually finding the critical numbers. So you got to take the derivative, and you've got to figure out where the derivative is 0 or undefined. Now the nice thing about your derivative being a big fraction is that a fraction equals 0 when the numerator equals 0, and it's undefined when the denominator equals 0. So you can see I set the numerator equal to 0 and solve. I am concerned about this step right here because this did show up on your last test where you took the square root of both sides, so you should have done plus or minus. So it's not just 1, it's plus or minus 1. And then when I set the denominator equal to 0 to figure out where the first derivative is undefined, I started solving here, took the square root of both sides, plus or minus. But what's the square root of -1? And where does I show up on a graph? It doesn't. So the min and the max can't show up at that x value if that x value doesn't show up on a graph. So this just didn't give us any real critical numbers. We still needed to do the work, and a lot of times for FRQs you can get a point by showing this, so even if you could do that in your head and you knew it wasn't going to go anywhere, you still need to make a habit of showing it. But basically that's the hard part. Now just plug all these x values into the function, solve for y. This should be a half, negative a half, negative 2/5 and positive 2/5. Is that correct? Okay. Now I would say that some of you might still miss this one because fractions aren't exactly everyone's strong suit. But of these, definitely the negative ones are not going to be the max. Would you rather have half a pizza or 2/5 of a pizza? Assuming you want the most. Half. So this is your absolute max value is a half. It occurs at x equals 1. And then your smallest number, which one of these two is the smallest? Negative a half, good. Okay. So that would be your absolute min, and we know when it occurs too if we needed to know that. So as I've been saying, this is consistent. Candidates test basically every single time. Every single time, test critical numbers and endpoints, because that's what extreme value theorem tells you to do. The only thing that makes some questions easier or harder than others is the first derivative could be harder to take, not any harder than you've already seen, and then also solving where the first derivative is 0 or undefined can vary in difficulty. Okay, so that being said, question 4, I started doing the same thing. They gave me 2 endpoints, so that's ready to go. Critical numbers is where it could be more work and could be harder. Critical numbers come when the first derivative is 0 or undefined. You can see I took the derivative. There's no chain rule needed. Cosine is never undefined. If you remember what the cosine graph looks like, he exists everywhere. But he can equal 0. So if you were to think of the unit circle, don't worry about this question at all, but if you went around the unit circle, when does cosine, just regular cosine, when does he equal 0? Okay, at pi over 2 and also and also 3 pi over 2. So if I can make this be cosine of pi over 2 or cosine of 3 pi over 2, that would be the two places where the cosine of that angle is x. So I would do this algebraically. If x plus pi over 4 equals pi over 2, I'm saying what could I add to pi over 4 to get pi over 2? Because the cosine of pi over 2 will be 0. This gives me an equation to solve. So if I plug in pi over 4 for x, pi over 4 plus pi over 4 is pi over 2. Cosine of pi over 2 is 0. So you may not have thought to take this approach, but maybe you can at least see why it's good. Okay, it's also 0 at 3 pi over 2. So if I can make all of this stuff equal to 3 pi over 2, then the cosine of it will equal 0. So I also asked myself, what plus pi over 4 is going to make that inside be 3 pi over 2? That making the equation, solving the equation, this is the purpose of algebra. It's meant to make this easier. It's meant so you don't have to do it in your head. You might want to get a common denominator. 6 pi over 4 minus 1 pi over 4 would be 5 pi over 4. Now, I'm not saying that the cosine of 5 pi over 4 is 0. I'm saying the cosine of 5 pi over 4 plus 1 pi over 4 is 0. Anybody find both of those critical numbers? Just one person? 2, 3, 4? Okay, good. Okay, now to finish, plug in your points into the function, not the derivative. This would be the sine of pi over 2. Plug in 5 pi over 4. 5 pi over 4 plus 1 pi over 4 is 6 pi over 4, which reduces to 3 pi over 2. The sine of 3 pi over 2 is negative 1. Plug in 0. You would get the sine of pi over 4. What is the sine of pi over 4? Okay. Is that bigger or smaller than 1? It is smaller. Do you know what the decimal is?
0.7.
Right, it's about 0.7. You should also know it's less than 1 because if you're talking about the unit circle, like this distance is 1, unit circle has a distance of 1, right? So 1 is as far as you can go. Anything other than that is less than that. Okay, and then 7 pi over 4, you plug it in. 7 pi over 4 plus 1 pi over 4 is 8 pi over 4, which reduces to 2 pi, and the sine at 2 pi is 0. So I guess you could argue that that part of this question is tough if you don't know the unit circle, but you'll need to know the unit circle for lots of other stuff. Now I'm basically done. I can see the smallest value, so there's the absolute min, and I don't have to worry about it existing at some other x value. And then the biggest y value is going to be the absolute max. 1 was the biggest, -1 was the smallest. Okay, so take a second, see if there's, again, we're going to practice the rest of this next time. You don't have to go further on this unless you just feel like you need to. You're trying to get a step ahead. But you might want to summarize any of this that doesn't seem easy to you in words. So I would suggest you do that. But then after that, we need to split in 2 different ways here. So if you have a question that you started doing on assignment 40 outside of the class, finishing that up, that you needed help with, I will answer those questions for you. But once your questions have been answered, you need to move on to this book assignment. So on your blank piece of paper, go ahead and copy the book assignment down real quick, even if you have homework questions, because I can't leave this screen up the whole time. And it's a very short book assignment. My 3rd period yesterday, I think everyone finished it in class and didn't have homework, and then this morning 2nd period finished it as well. So as long as you stay on task here, you shouldn't, I don't think you'll have homework. But. And then just to be clear, these book assignment questions are not about the stuff I just talked about. They're about the stuff from last class. It's just practicing finding critical numbers, finding where the graph is increasing, decreasing, finding where it's extreme maximum or local maximum. It's the stuff we talked about last class, not assignment 42 stuff. Okay, so I'll leave the book assignment up on the board for just a minute. Then I'll take homework questions. Okay, I'll put it back up if you didn't finish getting it copied down. Okay, so when you were practicing finding critical numbers, doing the sign chart, figuring out when your graph is increasing and decreasing, and pairing that up to find relative max and relative mins, assignment 40, there was a few questions you might not have gotten to until after you left class, so I want to offer some help on that. Is there any of those questions from assignment 40 I can help on? Okay, if you change your mind, I'd still be happy to help you individually. I'll switch back to this. So I'll give you a couple minutes, head start, then I'll come around and I'll come around and help. Let me go turn this on. Per usual, you cannot keep the book handout. I don't know why you would, because I think you'll be able to finish it up easily in class. So make sure I get those
No, I was like, there's 2 or 3. Someone really bad.
It's not my fault. Yes, I'm just getting digital. I like my big one. because my motor skill issues. I require thickness.
So you actually have motor skill issues.
Yes. I think it's This is just like
It's
what we did like the other day. It's not like what we just like.
So this is not the graphic we were looking Yeah, that's
These storms. They just
I like baby food. I like bush. Smash it up. Spoon.
drink it.
Just erase it.
Things can be erased. You know, I used to do that when I lived for over 2 years, I did that at people. That's like putting lots of people.
It's just erased by the like. That's interesting. But they're really close. I'd be scared.
You're right, okay, that. Wait, I just started doing it.
I know. Yeah, exactly. Why so? Mr. Johnson, what are we finding in these first questions?
I want you to figure out when it's increasing and decreasing.
Okay, yeah, so it's decreasing.
Well, okay, but don't use the picture. The picture is the checklist. So find the critical numbers, do the little sign chart, like we did here.
Oh, okay.
Test numbers around, then you can see when it's increasing, decreasing.
Oh.
But then once you have your calculus work, it should match up with the actual graph. It should be decreasing from negative infinity to 3. And
So we don't need the graph, right? It's just a
the graph is just a visual to make sure your answer makes sense.
Okay. Wait, if there's not a variable,
That's fine. That makes sense. You don't have to write this down for me at all.
Okay, what do you-
Yeah, I mean, you normally don't have a graph.
It's just
Yeah, you're just seeing what you're finding.
Because then I can just, that's how I look at it. What? Why? What is it?
Okay.
Checking on what I have to do.
Okay, now it's time for that. That's what advisors say.
What's my date then? Where's your date?
Everybody on?
Yeah. No, nobody knows it then.
What's 10? Who's 10? How many is 10?
I think.
Oh, so you don't even know. You're Hey, well, month is
Because I'm so lonely with my
It's the,
friends.
it's the 24th of
quick. What's 2 times 4? 8. Minus 6. 2. 2 is 4 minus 6. Minus 6.
I thought you said what's 2 times 4? You said what's 2 times 4?
Yeah, and then I said what's the
Oh.
Catch me doing something.
Why ever?
I got it erased.
You tripping in this class? Half for reason, half for shit. This class
That's the thing that he's talking about.
But you get more work details. Yeah.
X is the third of the
Yeah.
four. Like, powerful here. Powerful here. That should be I did quotient rule there. Okay, you can do quotient rule if you want to. Quotient rule, you probably do that. Derivative of the numerator times the denominator of the minus.
My grade didn't really change at all.
Right, squared. All of its denominator squared. But then this times 4. Either way, to me, that's a lot more work than just.
I'm making it great.
See, that's not really because
Something else that we don't put on here.
done. So we got a 10 out of 30 on it.
Was it the?
Was that on the sheet? Didn't check.
Oh.
Just got anything I can help with?
And I just like,
Never did the I never did the peer review. Any of it at all.
Oh, I know some of you guys have seen this, but since I have not said anything about it this year, and I know some people like it, I just want to make sure you're aware. You know, on our class website, I tried to put all of the stuff that I think is helpful. But one of the things I will put with book assignments. So here's our class website. You should have bookmarked. If you scroll all the way down to this book assignment, one of the well, first off, most of them are all worked out. So if there's a couple you need help with, if you run out of time, you should be able to get help with those. Nobody's ever asked about the last two, I think, because once they see these first 2 parts of 90, they're okay on the last 2 parts of 90, but otherwise they're all worked out. But one of these links says odd solutions. So just so you know, if you click that link, it actually takes you to the odd solutions from the textbook company. But the nice thing is, so you have to change this to see a certain question. But like I asked you to do question 9. The nice thing about this compared to even like the back of the book is it doesn't just have the answer at the end. It also tries to show some work. It shows what the derivative is. It shows what it thinks the critical number is. So if your answer's off, sometimes you can just compare your work to it, and that's enough of a hint for you to figure out what you did wrong. So anyway, you don't even have to use that. I just wanted you to know that I do try to link that to our class website where it says odd solutions. So if that sounds helpful to you, then please utilize it. Okay, even from now, you guys still have over 30 minutes. So, does anybody need me to come over and help?
Yeah, I think, well, it's not a question we're gonna take, it's it'll only be question before.
Okay, you're just figuring out when it's increasing and when it's decreasing.
I knew it didn't make sense.
Where it is, you found the critical point. The critical point was 3.
Yeah.
Okay, so then you should do this whole sign chart.
Oh, wait, no.
Right. Sign chart. If you know where the critical number is, test around it so that you can see when it's going up and when it's going down and all that kind of stuff. But then it should match with the graph. So don't use the graph to get your answer, but in the end, it should be decreasing from negative 3,
But what happens if
increasing
that's
from 3 to
what happens?
You need to make sure that you're getting
Do you just multiply it out?
Yeah, you multiply that.
Equals
Yeah, equals.
And 11 would have to be the product rule.
Yes, I can.
Okay, so you did zero was first, second left alone, plus first left alone, times third was the second. You got chain rule on the second part. Times what? Negative 2x.
But you know how when it was here, to get it to equals one.
Okay, so your next step is fine, if you need to change that
It's like
numerator
that
to
on side, but it's zero.
Now, since you want the critical numbers and you want to know where all of that equals 0 or undefined, that's kind of hard to do as it is. I would suggest that you get a common denominator here so that you can switch it into one big fraction. Because if you can make it one big fraction, a fraction equals 0, the numerator equals 0, and it's undefined when the denominator equals 0. It's a lot easier to solve. Yeah, I'd probably let these two cancel. Yeah, multiply the top and the bottom by.
How do you know? I don't know negative of all.
Well, because it's.
Well, let's say you do 1. Let's say you do 1. It'd be 3 divided by
So
4.
this denominator is just 1 right now. So when you make his denominator that, then multiply his numerator by that too.
Correct. Up here.
And you want to start the side.
It already has the denominator 1, so you want to multiply how
Double
it
plus.
This one also be 1. Zero. No, this one's gonna be negative.
What? Why?
Because, well, did you do 0 for the one in between
Yeah.
negative 2 and 2?
Yeah. 3 times, it's just 0 divided by 4. Oh,
Which is
minus.
just 0 minus 3.
Now that it's one big fraction,
To 3.
I know it's equal 0, the numerator equals 0, which I can now see never happens. But it's also undefined when the denominator equals 0, which is like 4 or negative 4.
Oh wait, no, you don't have to do that. You don't have to do that.
No, he's not getting point out, but yes, you are.
Why are you doing it? No, because it's not
You
asking.
can also,
It's not asking for that.
you can
It's
move
just saying
all
like.
of this, call it x plus 1 to the negative 2, and then you go to your power to which is I get the same answer either way.
Wait, I thought you said it is. It's like 0.
Okay, so that's power.
This is cool.
Bring the 2 down, lower the power by 1, and then multiply by the derivative of the
Yes,
side.
you estimate it, and then you have to find the upper and inner points.
Wait, but is it?
That's the analytical part. Now you have to say when I would.
No, it's not kosher. It'll be chain roll.
Like if you so when you take a power to a power, you really multiply the exponents. But if you ever forget that property, you can just give yourself a quick example here. Like if you do this squared,
That's
like this times themselves. When you do the x to the six, and then you can remember, oh yeah, you're just multiplying the exponents.
No, chain roll is you take the derivative. Like you
Yeah, but you have to
bring the
still
two
leave
down.
it. I know,
And
but
then you leave this on that side. Right. Yes. That's what you're saying.
Oh my goodness.
I was thinking multiply it by that.
No, you have to bring this down.
No, I'm
Yes.
saying multiply it by that.
Is that your hammer?
2x.
Yes.
I did 4.
I'm literally in that same.
So it's just.
Hold on. Because you grab this.
I'm gonna keep going on.
So this is one that they don't show you that.
The right way.
You can split it this way. It doesn't even exist over here. That's why you're getting an imaginary answer. And when you test around, this person number is yeah, but I'm saying that he doesn't exist yet.
Yeah.
When
But,
you test this one, you're gonna get imaginary also.
yes. But would it, so that would make sense. Area then? It's not.
Who's the weird scout?
Yeah.
Where the bus runs it there.
Yeah. He's gonna go to the bus makes it.
Let me work that one for a second. Think it for just a second. There's probably one
I wasn't
step on
gonna
here
say
that I
it.
can't find. Okay, I'm still coming, give me just a second. Let me finish my thought with her first. You can just skip your questions if you need to.
Just say you hate us.
I'm saying it. Trying to pour it up.
You're gonna be really disappointed when you come over here and hear his question.
No.
Yeah. It's gonna be like, how are you even passing this class? Absolutely. Whoa.
No, that doesn't look like a graph at all, does it? No, it doesn't.
Well, that isn't. This is not. That's not how that
That's literally cheating.
works.
On,
No.
on God. On God.
We're both wrong, but I know that you're like way more wrong.
Well, that looks way wrong, don't it? That's a problem.
That's a problem. That's a problem. This is a. What's a problem?
What is a parabola?
I mean, like I know
Wait,
what it
this
is.
is just completely not even what
Have you
he's
seen
doing. It just, it's being set to zero. Like, that is the token. Like, isn't that,
Wait.
it doesn't even do nothing.
Wait, just set that to zero? Wait.
Oh, wait, no.
The reason this is a minus is.
It's not,
Oh.
it's not chain rule at all.
Oh.
It's not chain rule at all.
No, but no, there is gonna be chain rule. Look, just keep watching.
Yeah, but I mean, like, we
you're saying.
No, that's it.
No, wait, no.
Because it equals one. You only get to change rule if it says
Hear me out,
that's
you
just
guys
one.
can
So you can't simplify.
Yes, exactly. That's what I did. It would
Really?
be
What does
one.
that say? What does that say?
Look, this is what I said. This is what I said. I was that's literally the same. Well, it would have been the
It's
same.
not the
It
same
would
at
have
all.
been if I did that first. You
If you did it differently, it would have been.
look at what he did.
I thought it was chain rule.
He took the derivative of this, right? Where is it? 7
Okay, if
of
it
this.
was chain rule, is that not what it was?
And then he kept it the same. And then he multiplied it by 2x. Maxwell.
Is that not? How would you do the chain rule if you needed to do chain rule?
I showed you already. Look, you would move the 2 down, keep what's inside there, and then you take the derivative of what's on the inside and multiply it by this whole thing. But the derivative of x is just 1. So if you multiplied it by 1, it would stay the same.
Okay, the long way to do this would be the quotient rule. Derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone. Now, this derivative of this denominator is just power rule. You bring the 2 down, you lower the power by 1, and then the chain rule that you're worried about, you need to multiply by the derivative of the inside. But for this, the derivative of the inside is just 1, so you don't have to have chain
I
rule.
know that. I'm
Why did
saying-
you write 2x?
Because we thought initially that we had to do the chain rule just of this, correct? That's what we were initially thinking.
Yeah.
I was remembering the chain rule as you leave it alone and you multiply by the derivative of the thing.
Of what's on the inside.
Yeah.
Of what's on the inside of the parentheses.
I'm a little.
How did you get 2x?
Okay, I just.
It sounds like y'all figured it out.
I really think you can cancel them out, but.
Yeah, the derivative of the whole denominator would
Would
have
be
been
2x. I get it.
No, it wouldn't.
It would be.
The derivative of the denominator.
It would be
You're saying
x plus 1 squared.
the derivative of this,
Yeah, bring the 2 down.
right? And then you multiply it by the derivative of x.
And
Which
what-
is that.
You're not listening to me. The derivative of this is 2x. Because that just turns to 0 and that's just 1. 1 plus 0 is 1, so it's 2
But
times
if you get a common
1.
denominator, just push
Times
into
1.
one big fraction,
Wait.
at least you know it equals 0, remember 0 Somebody's making you get a common denominator, and push it on the wall, it's probably easier.
I hope you don't rub off on me. Like you were really close to me just now. I hope none of
That's stupidity.
just like
I have
Over 2.
yeah, you did. Fuck, that was the most brain dead argument
I just couldn't remember what I thought I remembered chain rule quickly and I didn't, but we were arguing 2 completely different things.
And neither one of us were right.
Yeah.
So it didn't even matter.
Well, there's 4 critical numbers. Plus or minus 4 would be where the denominator is 0. So that's where it's undefined.
That's like you think you do that. I like derivatives. I don't think they're
Okay, so when you take the derivative of this part, you bring the 1/2 down, you lower the power by 1.
there's a lot of different rules.
I'm just pissed.
Yeah, I know. I
You
know.
too.
This.
I'm pissing because you're
We could do this, but we're
Turn it
so just wait. 16 minus x squared.
Yeah, but I can't. Chain rule.
I got better than you did on that.
I know. I'm questioning everything.
That's what I thought when you got a better grade on it.
On the physics.
16 minus x squared.
Not to, but since this is a term,
No, it's minus x.
something
Minus x.
personally, what I would do is get a common denominator and push it back.
Minus x is right here.
That one is
So yeah, it would be negative 2 negative x.
Not that you have to do that, but you're losing it. You're losing the
Like,
What do you have?
let me.
Yeah, this guy has the denominator of 1. So the common denominator, you need to multiply this by all of that, and you gotta multiply the top of it. I went to tell you though, I think when you did this derivative, I think you did the change of this. I did the derivative over that. Create a negative. No, it's plus or minus 2 squared root of 2.
I'm very calling 911, I guess. Monkey business.
I don't have a problem with your problem.
I think he's just saying what not to do.
Those are two of the
Maybe,
big
yeah, because it's right.
something with your problem.
I like this black background.
Yeah, compared to that. Yeah. That is like.
Okay, so part of the issue is here, it looks like you're setting s equal to 0.
Man, I don't know what he's doing here.
You don't have to set this to 0. You have the square root of this number.
I've never been able, I
all
don't
of that.
My mom please, like.
If I was doing an algebra problem, something that's factorable.
0, 2, and
If it's factorable, it's good if you make it 0, because if this equals 0, then either this could be 0 or this. But that's the special property of 0. If you've got x plus 3 equals x minus 2, you can't just set this equal to 0 and get an answer. Okay, never mind. That example is what I said what to do, but
So,
hey, where you been?
Doctor's what?
Look, I got
So.
We're trying to fix it. I'm gonna put it on the board there so I can reference it on the board. Sit down, put your phone up. Quick question. What time? No. No, you cannot have your phone out for any reason.
How am I supposed to show you?
Now's not the time for it then. It's non, even for academics, your phone has to stay up. And it's not my rule. Yeah, 1 second.
Why do you even know why? Something times 13.1.
because you're supposed to say that. That's like 77. It includes x plus 0.
Oh!
Wait, are you gonna see the word, bro?
No, because you're supposed to solve for x by setting it equal to 0. Not making
Right,
x.
not making x and something.
That's what you're right. That's what you're doing.
I don't know. Just keep going.
Oh, because he.
That's the square root. Not the square, that's it. Let's see what, it's easy. Yeah, it's easy.
No, that's a critical number. That's the critical number.
Yeah, well, that is the critical number.
Okay. What
It's like, you remember in the beginning when we were like, how did he do this?
Yeah, I don't know why he got that, why he still got the same
Why don't you tell me what the question is, why you said
But,
that?
but that is the best number that you get from a derivative.
You put the derivatives or Oh, okay. You did it on Google Classroom.
Yes, sir.
Okay, sir.
So all that
You
work
send
was
me
just
an email
him
and tell me
doing
to
the
check
points to
that.
the left and right.
Because I remember right now, but I wasn't remember then. Alright.
Oh.
Is the one half not?
I'm just confused about how he just did it right in the function. He's right.
I don't do this, yeah, I don't know.
Right, so x minus 2.
Maybe if we could hear what
X minus 2 squared minus 4. X minus 2 squared.
Oh, right.
X minus 2 squared minus 2.
Wait, now I.
X squared. X minus 2.
So right, if you plug in 0, it's a negative.
Wait, that's just fine. Point.
2x minus 2.
Plug in.
Those questions about number 11, so I showed my word for finding the critical numbers. There's 4 critical numbers to question 11. And the people's papers who I looked at, most of the issues were coming from this, not remembering to multiply by the chain rule. So if you have a different derivative, you're gonna get different critical numbers, and then your answers are not going to make sense with the actual graph. If I start running 1 minute late,
Multiply by x again.
why? That's turned again.
So it's negative x squared.
On Google Classroom, that's fine.
So we're literally just doing this.
This is also negative 16 minus 2.
Okay, so these are the functions. You're trying to look at right here. You see how the function is.
Oh, yeah.
Okay, so let me just tell you about the derivative. Increasing with that thing about the derivative. And it's switching at x equals 2. So,
Oh, wait. Sorry. It's maybe because it's
Plus or minus 4. Yeah, that's right. I have
Plug
that
0
one. I have that
in.
one. And
Then it's
then
gonna always go
negative that equals.
until x equals 2.
2 and
Still make
Is that what we said? Okay.
Okay, from 2 square root of 2.
Okay, so that's positive after 2, right?
It's square root of 4. Square root of
And another way that should make sense is if your function rates
negative 2.
probably a derivative of and you power lower
Eight. Yeah.
But you're just thinking about when the function
Negative.
increasing, decreasing.
Positive, negative, square root of 8.
So it decreases and increases and decreases.
No, it's just square root. Wait. Whoa. What? So you would have said plus or minus square root of it. For what?
So it's
Plus or minus square root.
minus x squared to the
1/2 of these
plus x.
You bring down the 1/2.
If you draw, you just draw the line was
And you would change it down. 2x. Oh, yeah.
You still on the baseball team?
Yes, sir. Yes, sir.
Good to know.
Still playing.
Huh?
Still playing.
What position do you play?
Right, because it goes.
In the outfield.
Like,
Like
I always.
behind the fence outfield?
Well, no, in the fence. Usually I top five. Everything's over my head. I gotta run back, get. I throw them out.
Since it
I have a little bit of arm. I can throw the ball pretty far.
isn't it?
My goal this year is to hit the bar from home plate.
So right here, it changed direction.
Hit the home plate?
Or no, hit the bar. I can throw the ball, hit the bar from home plate.
What bar?
You know the
It goes
bar?
like,
Because
No.
the big building.
Goes
If you
down.
were in the right
If
field,
you
ignore this
Okay.
for right now, right?
Down.
Ignore the 2x.
it's like 300 something
Then
feet.
and you
Yeah.
multiply all of
So
these.
my goal is to hit that. So I'm allowed to do steps. So
You can't, I don't think you can throw a baseball 300 feet.
So go.
I can throw it 300 feet. I just need to throw it 320.
You know, like 300 feet is like 100 yards. That's a full football field.
I can throw a baseball full football field right now. So that's one impressive thing.
In one throw.
In one throw. Or like one shuffle. I can allow myself to do
And
steps.
then you multiply the x.
still going down.
This right
We're
here.
working
And then the
pitching
x.
right now.
And then once you
We're
multiply
throwing a lot. We're starting to
the
throw live
negative
today.
then it's always gonna be out.
Like this. So,
I think you'd like my cutter.
like that.
Your putter?
Cutter. It's nasty. Curveball and cutter. It's not bad.
I don't know what a cutter is.
Okay, so a cutter. Yeah, you know how you grip it like a curveball and you throw it like this for a curveball. Well, cutter, you throw it like this, and you throw it. The ball spins sideways, and it just kind of goes. The curveball goes down. This cutter goes this way. Change goes this way. Two-seam goes rides this way. And then
Are you sure that's not a slider?
I mean, it's kind of like the same thing. It's just a different way to grip it, I guess.
You don't have a knuckleball?
I do not. You got okay. You know what's a good knuckleball?
Play every
Daxton. Daxton got a fantastic knuckleball.
Huh.
Ask him about it.
Yeah.
And Camden pitches too,
Oh yeah?
a little bit. Ask him about it.
Oh man, I gotta show you.
Uh-oh. What's up?
You know, dude, you probably already heard, but
For the Matthew?
yeah.
I saw this.
You saw it?
I think so.
The joke of the day.
Yeah, you showed me the joke of the
Jessica
day.
showed me it.
It was me, Daxton, and
That's-
Thompson. Yes. Oh man, that was hilarious. I want to see it again though.
I just did that. Like, I see it.
Once you multiply like the top and the bottom.
There was Camden for fifth period.
Oh yeah.
First period told me to do that. This is what I made for first
Oh
period.
yeah. There we are. There's the whole. Hold on, I gotta get a picture of this.
I'm on the other side.
Huh?
But didn't you just
On the right, you don't need to multiply the right side
Left me out.
because you're just
Gotta get
multiplying
Pearson.
the left side.
This is for a whole different class that y'all are not a part
In the
of.
form of
But for this
this.
one.
The only reason Johnny got in here is because he was between these two guys that were a part of this class.
I got lucky.
No, you're only multiplying this by 1.
Oh, that's cool. That's
like,
cool.
Like
Make Pearson one. He can do one.
Well, he
You can
didn't send.
Photoshop us together or something.
1.
Well, I did. I photoshopped.
I can make.
I photoshopped that. You can't see this.
Oh yeah.
See,
Don't be a jerk.
so
You don't see that girl's face cut off.
You're multiplying
Oh, I
it by
did not.
1.
You don't remember? You were not standing by Daxton.
You're right. I
This is
wasn't.
one.
I wasn't.
But now it's over.
I mean, that's a 10-second Photoshop. Right?
That's cool.
And then, but you also have to multiply this by itself.
Identify that
Okay, we've got about 5 minutes, so let me remind you that
You're supposed to multiply the denominator and the numerator by this.
I will be taking up assignments 40 and 41 at the start of the next class unless you put them in Google Classroom earlier than that.
No, that's.
You're welcome to keep going here.
But then it's that minus x squared n.
Did y'all do the eye test last time puzzle?
Which one? Okay.
Have y'all done the eye test puzzle? Okay, if you want to do today's puzzle, it's a video, an eye test video.
Hello, welcome at Brain Gate. Are you ready to test your eyes for a new game?
What a revelation.
This game is simple, they all look the same, but one is different. Can you test your eyes? Which color blue is different?
So I would have guessed that.
Did you have the first question right? Let's turn to yellow. Wow, this one is actually difficult. Let's continue testing those eyes. 1, 2, 3, 4, 5, 6, 7, 8 or 9. Which one is different?
But not so like that. I mean, two.
If you like our quiz, hit the subscribe button so we can grow together. I see green. Ah, wait, one is a little bit dark.
You need me to find you a date?
That's what our last teacher was doing.
Oh, Miss Reed was telling me about that. You're doing the ACT, right?
Well, I'm not.
It's easy to boost your score. Another easy one if you ask us.
Some of these are hard.
Your favorite color, orange, the color of the madness. But which one is different?
Can't know anything.
Question 9. Let's keep going, everyone. Don't forget to keep the timer.
Dude, that umbrella.
We made it to question 10. Yep. Guess my eyes are good. I found this one. Wow. Some are not easy if you ask me. Question 12, let's circle back to a little bit of the yellow tone again. I had to look for like, let's say 5 seconds. I finally found it. Whoa. You can find this one, legend. Right, 15, let's keep going. I think this is a fun game to play with your friends as well, by the way. 16 to boost your score. Very easy.